Do you guys have anything in mind that question not for it? Let me be very specific. Do you guys have any particular topic in mind that you would want me to teach? Otherwise, I'll pick mine. Okay. So this is the syllabus. This is the syllabus where I have everything listed down from 5th to 8th grade, and we have covered most of it so far. And basically from next week we will start revising it. So we will start going from beginning, and we'll kind of start doing more practice now. Okay. Okay, go ahead, please. So we will start going from the beginning again, okay? And this time will be more practice driven. So far it was more on the concept side of it. Now we'll do more practice so that when you guys go for the exam, you have gotten your hands dirty enough to be able to solve it very quickly, okay? And obviously, if it requires us to touch upon the concept, we'll do that. So today, in today's class, we are going to talk about, last but one class, we talked about congruence and similarity, and we'll use the same concept, and we'll learn the Pythagorean theorem one more time, and irrational numbers. Irrational numbers. So Pythagorean theorem and irrational numbers. Okay?
Isn't this c equals to a plus b?
It's not a debate. We'll talk about it. When it's time, I'll ask you who all knows Pythagorean theorem. Okay?
Oh, okay.
So we'll talk about Pythagorean theorem, and we'll talk about irrational numbers. Now, tell me who all knows what is Pythagorean theorem. Okay? Okay? Yeah, I saw it. I'll come to you. Hands down, settle down. I know you guys know, and there's a reason why you know. Okay, Sanvi also knows about Pythagorean theorem. Who else? Pranav, do you know what is the Pythagorean theorem? Dikshita, do you know? Anirudh, you know? Vishal also knows?
Yeah, I know.
Okay. Okay, very nice. So, okay, now you guys have to assume, okay, hands down. Now you guys have to assume that your teacher doesn't know about Pythagorean theorem. And can somebody explain me in simple terms? I'm not a very intelligent guy. I only digest one or two sentences at a time. I don't need a big paragraph to understand Pythagorean theorem. Think about it. You have raised your hand. I'll give you a chance. But think about it and tell me a brief this thing. And if you get me confused, I'll not let you explain it one more time then. Think about it and explain me. Assume I don't know what Pythagorean theorem.
Pythagorian, whatever that name is.
Pythagorean theorem.
Is finding two sides of the triangle that the C is the total of the triangle and B and A are the part you're trying to find, like the hypotenuse. That's a very
Stop it there. No,
Was
no,
that-
you have to give feedback to him.
was that
For that, I'm here. Okay.
was that each like that?
Okay. Just leave it there. Leave it there because I was not getting a clear sense. Let me hear him.
Is the formula to find the missing side of a triangle.
Okay. Let's hear it from Anirudh. Anirudh, you have to assume that your teacher doesn't know what is a Pythagorean theorem, and you are trying to explain it to me. What is Pythagorean theorem and what is the use of it? So you are trying to enable me to understand Pythagorean theorem. Okay. Try it.
Okay, so in this short summary, the Pythagorean theorem is using two sides of a right triangle to find out what the hypotenuse is, like the length of the hypotenuse.
Okay.
And to do that, the formula is a squared plus b squared equals c squared. A equals the opposite side. Where in the right triangle, if you imagine it like this, and that, this would be opposite. This would be adjacent. And you use those two sides to find out what this hypotenuse is.
Okay. So I heard. Okay. So I will not poke you guys to get another explanation for this one. I know many of you can explain it, but I heard three versions of it. Three versions of the definition of Pythagorean theorem. Three of you tried explaining that to me, assuming I don't know about Pythagorean theorem. And why I insist on this kind of thing is because when you explain something to somebody, you yourself need to be very clear about how would you describe it. it has to be a story. If you guys remember, I don't know in your era whether you hear stories or not. When we were small, when I was small, right? When I was small, that was 40 years ago, right? So when I was small, my grandma will tell me some stories, right? Grandparents will tell some stories, and some of those stories are still with me. I still remember some of those stories. Sometimes mom will say, auntie will say, and those stories last longer. So basically, storytelling is an art. When you explain things in a form of story where you have sequence of events, when you relate, it becomes easy. So yeah, Vishal is trying to explain. Let's hear Vishal's version also. So Vishal, you assume that your teacher doesn't know what is the Pythagorean theorem. I don't know what is the Pythagorean theorem. I'm hearing for the first time, let's say. How would you explain that to me? Vivan, you have raised your hand. Do you want to explain that to me? Yeah.
Can I get some water?
I'm sorry?
Can I get some water?
Yeah, sure. So now it's your teacher's job. Whatever I was pretending, let me come out of it. So I know what is the Pythagorean theorem. Now I would assume the same way that you guys don't know or somebody doesn't know. How would I explain that? I will say Pythagorean theorem is a theorem for right angle triangle which gives you a relationship between all the three sides of a triangle in the form of a square plus b square equal to c square, where a is the side opposite to the angle, b is the side which is the adjacent side, and c is the hypotenuse. That would be my plain simple definition of Pythagorean theorem. So my context is Pythagorean theorem is for a right angle triangle. That's my starting point. Pythagorean theorem will not apply for a circle or rectangle or pentagon. Correct? So that is my starting point. People should not get confused about Pythagorean theorem and relate with it for dealing with a parallelogram. So first thing is you have to set the boundary. It is only for right angle triangle. It gives a relationship between the three sides as a square plus b square equal to c square, where a is the side opposite to the angle, b is the base or the adjacent side, and c is the hypotenuse. Do you think that is simple enough, or yeah?
Will this only work for right angle, or can you look for more triangles?
No, look it up. Pythagorean theorem has never existed for anything other than right angle triangle, to best of my knowledge. I'm already 48 now. In my lifetime, I don't think it's going to change. Okay? Alright. So, did I say it simple enough, or you want it to be simplified further? I can try doing that as well. No? No. Okay. I'll take that as a no. Now let's come to, this was only the context setting. It was only the storytelling part where I said Pythagorean theorem is a theorem for right angle triangle. So it's like a story. We are saying there was a kingdom where the king's name was Amitabh Bachchan. Okay. Then the second line of the story says where it gives a relationship where the king was a very nice person. He used to treat his people very nicely. So Pythagorean theorem is a theorem for right angle triangle which is showing the relationship between all the three sides of a right angle triangle. And the king was very humble. Every day morning he will wake up and donate wealth to poor people. Same way, Pythagorean theorem gave us an equation which says a square equal plus b square equal to c square. And this is a relationship. So it's like a story, right?
What is the end?
So at the end it says this gives a relationship where this is this, this is this, this is this. That's it.
Like at the end of the story?
We will have Pythagorean theorem 2 release sometime in future. Okay, we'll talk about it. Alright? Yep.
But if it was a cube, wouldn't it be c
Now you have to stop because you are going in the wrong direction for wasting your time and everybody else's time.
Oh wait,
Stop
I
it.
know what happens at the end.
Okay, so stop it there. That's not needed. Now, if you all knew this theorem that this is right angle triangle and this is the angle, this is A, this is B and this is C. A square plus B square equals to C square. What is that I am getting paid for? This is known to you already. What is that I am doing?
Reviewing.
My job is to tell you why this is even existing. Why it is true. How do you believe just somebody saying that a square plus b square equal to c square for right angle triangle. Who proved it? Math is not about stories though. Though I told this like a story, but there has to be some evidence for this. Now the question to you guys, a little tougher question. Who all knows why this is the case? Who knows how to prove it? All of you will have put your hands down, please. Put your hands down. Yeah, who will tell me how to prove this? Do you guys know why this is to be believed? Okay, so now simple answer to that is we are trying to prove the Pythagorean theorem. Shall we?
If I have a question.
You cannot supposed to have questions.
Right.
Because your questions keep on wasting time.
When I read a book about this, it said that it had squares on it. Was that the reason why?
No, stop it there. Alright. So we are trying to prove how this Pythagorean theorem came into existence. Okay? How do we prove that this is correct? That is what we will do. Are we ready for that, or you think that is not needed?
I think we can talk about it.
We talked about it, but you will be stuck. So again, the point is, there are concepts that I will teach once, I will teach twice, I'll teach 3 times, I'll teach 4 times before your school year gets over. That way, it helps you do more practice. Now, you just tell me in simple terms, what is the approach? What is the clue for proving this? Just give me the clue, 1 line clue
Like I didn't understand what clue is.
for proving the Pythagorean theorem.
I don't know.
Okay, then leave it there. Yeah, Anirudh, tell me.
The hypotenuse is bigger than the opposite and adjacent sides.
That is correct. That is a property. But that doesn't prove the Pythagorean theorem still. I'm asking you guys, how do you prove this? And there's a clue. That clue is the property of similar triangles is the clue that we learned in the last but one class. Now you put your hands down. You're not the only one in the class. Okay? So, properties of similar triangles is the clue for proving the Pythagorean theorem. Vivan, saying something? No. So then my only request would be, don't make those things because that will distract you. You will be more interested in seeing the AI features than what I'm kind of struggling with. Okay? Let's not do that because that's not good for you, not good for anybody else. Yeah.
Oh, is this supposed to be a right triangle?
This is right angle triangle.
It is. Looks
Is
like
it?
an isosceles.
It's not. That's
Okay, that's another waste of time. Don't do that. Alright, so we are trying to prove this Pythagorean theorem. The clue is the similar triangle property is the clue. Now let's do that. How will you prove it? Let's come to this. Now can somebody tell me what do you mean by similar triangle properties? What does a similar triangle tell? If there are 2 triangles which are similar, let me tell you this, if these 2 triangles are similar, what it means? The angles are same.
Zoom in, zoom out.
Then the angles are same. So this angle equals to this angle is equal to this angle, and this angle equal to this angle. The property of similar triangle that we learned in the last but one class. Can somebody tell me what that property says? If the 2 triangles are similar, what extra thing we need to be aware of? I'll come to you as a second or third option. Let's see if anybody in the class remembers. Yes, Dikshita.
Like the lengths match, like same length.
Lengths don't match, but there's a clue. Okay, let's see if anybody remembers. Yes, Vishal.
I wasn't here in yesterday's class. What did we
It was not in the yesterday's class. It was in the yesterday, day before yesterday. I mean, last Sunday's class where we talked about the property of similar triangles and congruence.
The angles.
If there are 2 triangles which are similar, meaning the angles, they have matching angles. That is why they are called similar triangles. Okay, let's see if everyone remembers. Yes, everyone.
Yeah, that's like proportional.
The sides are in the same proportion. Meaning, anybody has any other point of view? You're not supposed to have so many point of views. because a lot of unwanted point of views are wasting time. Okay, let me give you one chance. And if that is a waste of time, trust me, I'll not let you speak for next 20 minutes.
Zoom in or zoom out?
That is not new, that we talked about.
I was gonna say like angles.
So see, if the two triangles are similar, they are similar only if they have matching angles. Okay, so this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. That is why they are similar. And then it is like zoom in, zoom out, as you said. But that is the basic understanding. Yeah, Dikshita.
Same dimensions.
No, dimensions are not same. Only the angles are same. Okay. The sides will be in the same proportion, like what we once said. Meaning, if this is A, B, C, this is D, E, F. Let's say this is angle 1, this is also 1. This is angle 2, this is also angle 2. This is angle 3, this is also angle 3. So, this angle same, this angle same, this angle same. They are similar triangles, meaning they have angles matching, but the sides are the same proportion. What does it mean? AB divided by AB. AB is opposite to 1. Now here 1 is this one. Side opposite to this is DE. AB by DE will be equal to, take the second angle. Side opposite to that is this one. BC divided by EF. Or take the third angle. Side opposite that is AC. AC divided by
DE.
is third one is this one. So DF. So this is exactly what we learned in the last but one class, where we said that if the two triangles are similar, that means they have only matching angles. If the two triangles are congruent, they have every property matching, meaning the dimensions are also same. So Dikshita, what you were saying was more for congruence. If the two triangles are congruent, meaning they are exact replica of each other. They have every property matching. Wherein when you talk about similar triangles, you have only angles matching. Only angles matching. So when the angles are matching, it's like zoom in, zoom out, like what you do on the phone. Same small picture becomes bigger picture, but it's like a baby becoming bigger. That's it. Here, and the ratio and the property of the similar triangle says the sides will be in the same proportion. Meaning, side of this divided by this side of this divided by this side will be equal to same. That is the property you have to remember. Pranav, pay attention, beta. Okay. So everybody here. And that's why I keep requesting everybody to turn on the videos, because I would not know who is paying attention versus who is having fun behind the screen. I mean, I am not against you guys having fun, but you can have all the fun after the class. Alright. So, property of similar triangle says the sides will be in the same proportion. Now let's use that information to prove the Pythagorean theorem. This is a triangle. Now, do you guys know about the theorems of congruence? Who knows about the theorems of congruence?
What does congruence mean?
Congruence means something which is exactly the same. If I say two triangles are congruent,
Oh, they're equal.
they are equal, they have every property matching.
Pythagoras is an Italian.
Don't get super excited for no reason. Yep, somebody raising hand. Who is it? No? Okay. Yes. Dikshita.
Do Pythagorean theorem and the similar triangle relate to each other?
Yes. So similar triangle. Okay. Forget about congruence. So similar triangle gives you the property that if two triangles are similar, that means their sides will be in the same proportion. We will use that information to prove the Pythagorean theorem. Okay?
Okay.
Yep. Yeah, Vivan, you were saying something.
Isn't it 4 theorems of congruence?
Yeah, 4 theorem of congruence, but we don't need that for proving Pythagorean theorem. Okay, I was a little distracted. Okay. So we'll use the property of similar triangles for proving Pythagorean theorem. Let's see how it works. Okay. Let's see this. This is triangle ABC and this is 90 degree. Okay. This is a right angle triangle. Everybody here, okay? we have a triangle ABC where this angle is 90 degree. What I'm going to do is drop.
Yeah, you also make a 45 degrees.
Hold your horses, otherwise horses will start running unnecessarily. Yep. Alright, so here I'm dropping a perpendicular on the opposite side, and let's say it touches here on D. I have a triangle ABC, which is a right angle triangle. I have dropped a perpendicular from this corner to this side. So this is also 90 degree and this is also 90 degree. Now I have basically three triangles. One is triangle, the parent triangle ABC. The parent triangle ABC. Two baby triangles. One is this one and other is this one. So other baby triangle is triangle ABD. And the third triangle is triangle
DBC.
BCD. Okay. So this is the parent triangle, the one that you see, the bigger one. And I have dropped a perpendicular from here to the opposite side, which is touching at D. So now it is breaking into two child triangles. Okay. So far it is okay.
Yes, sir.
Okay. So we have one right angle triangle. We have drawn a perpendicular from here to here, touches on D. Now we have three triangles altogether. The parent triangle, the ABD, this one, the blue one. Let me color that.
But see,
What about ACD?
ACD.
Well,
You don't need
that's
that.
a full triangle.
There is no ACD. ACD is a line.
Yeah. But see, what did
Wait,
A?
hold your horses because they will run unnecessarily here and there. Now see, I learned something today. Okay, people say don't talk, hold your horses, because if you don't hold your horses, they start running in all directions, right? So now I can relate why people say hold your horses, because horses, if you don't hold them, they go all the places where you don't want them to go. So everybody hold your horses, pay attention. Okay, so there are two triangles. Okay, there is one baby triangle which I colored in green, and there is another baby triangle which the green one is ABD. Okay, this is the green one. Let me color it also so that it becomes little easy for you guys to relate. Okay, and then there is another baby triangle which I will color blue, and this is BCD. So let me color it here also. I think now it's optically better. Yeah. So let's look at the first two triangles. Let's say ABC, the parent triangle, and the baby triangle ABD. Okay, baby triangle ABD. When I say ABD, I am talking about the green one. So I am coloring it here also, so that you can visualize it. Talking about the green one. Okay. I am saying these two triangles are similar. Do you agree? Triangle ABD, ABC and triangle ABD, I am saying they are similar. Do you know why?
Wait, what?
Listen, keep your lips close to each other and keep the ears wide open. Hear me one more time, okay? Triangle ABC, the parent triangle, and the triangle ABD, the green one, okay? I am saying these are similar. The question is why? ABD. I am saying these two triangles are similar. Why? Okay,
What's the thing about the equation mark?
that's similar. I said this is similar to this one. Okay,
Because both of them have a 90-degree angle.
that doesn't make it similar.
It does. Oh. But
Okay.
also there's
Okay, you adjusted your quota of talking. Stop there. Yes, yes, Vishal. I'm saying triangle ABC, the parent triangle, and the baby triangle ABD, which is in green, they are similar. Tell me why.
Because ABD is a part of ABC, like 1/3, and is it like in 1 3 by 3? Because like they both are similar. because 1/3 is in 3 by 3.
Not
It's like-
convincing. Not
It's in the
convincing.
smaller part of it.
No, it's not convincing. My only understanding of similar triangle is the two triangles are similar when they both have matching three angles. Meaning one angle of triangle A has an equivalent angle in triangle B. Second angle of triangle A has an equivalent angle in triangle B. Third angle of triangle A has an equivalent angle in triangle B. Now you tell me how I am saying that these two triangles are similar. Now pay attention to what I am doing, okay? Now let me get a red marker. Now look at the green one, the baby one, okay? This has a 90 degree. This angle is 90 degree. Let me write it down here. So this has angle, baby angle triangle. Okay, now let me do it the same sequence. ABC on the left hand side, ABD on the right hand side. So ABC. So the angle ABC, this angle is 90 degree, and that is equal to this angle, right? Angle ADB. Agree? Don't agree? In both the triangles, in the larger triangle, this angle is 90 degree. In the smaller, this triangle, this angle is 90 degree. So they both have one angle matching. Agree?
Yes, sir.
Everybody right? Okay. Now, in both the triangles, see what, this is my wall, okay? This side I have properties of the bigger triangle, this side I have properties of the smaller triangle, okay? Here, angle BAC equals angle BAD. Do you guys agree? Angle BAC and angle BAD both are the same angle. Yeah?
They do.
Two angles are matched.
No, three.
What do you need?
Because the point A would
No, don't give unnecessary explanation. In a triangle, in two triangles, if two angles are matched, you don't need explanation for the third angle itself. Because any triangle in the world, sum of the three angles is 180 degree. Two angles are matched, third angle has to match by default.
Oh yeah, because if it's 4, it automatically goes to 60.
What?
Where are you going, buddy? Why would you have fourth angle in a triangle?
Oh no, I'm like.
So think, better think. That is more important. Okay? So, now again, let's recollect ourselves. There are two triangles. One is the big triangle, and then we made two small triangles. We are looking at this small triangle and the big triangle. The big triangle has angle ABC as a 90 degree. The small triangle has ADB as a 90 degree. So one angle has matched. Again, in the larger triangle, if you see, the angle BAC is equal to the angle BAD. Basically, this is the same angle which is in both the triangles. Correct? Do you see it? Okay. Now, you know that any triangle in the world, sum of the three angles is 180 degree. If it is 179.99, then also that is not a triangle. It has to be exact 180. You don't have to, you're not supposed to have a question. Put your hands down. I have explained that it's a property of a triangle. Why the three angles of a triangle is 180 degree? Only we have to ask God. Navratri, when Navratri gets over, we'll worship God. Somebody will come, give us a wish. We'll ask why it's not 180 degree. It's a basic theorem of geometry which says sum of three angles will be 180 degree. That's proven. Okay? That's a written in stone. Let's not argue further. Coming back to this one. Any triangle in the world will have sum of all three angles as 180 degree. Here if you see, both the triangles, now only angle that is left in the larger triangle is this one. Angle BCA and angle this one. ABD. I'm saying these two angles will also match. Why? Because both are triangles. Both are supposed to have sum of all the angles as 180 degree. Two angles have matched. So third angle is 180 minus the sum of the two angles.
You already wrote that.
Hmm?
You already wrote that.
I did not write it. I have not written equal to sign.
BAC equals to ABD.
BAC equal to BAD. So when I'm looking at the larger triangle, I'm saying BAC. I'm going till here. When I'm looking at a smaller triangle, I'm just going till here.
Yeah, they're the same
It's
triangles.
the same angle actually. It's the same angle. So two angles of the triangle, both the triangles are matched. I think I will not let anybody ask question, but let me confirm with you guys. Are you with me so far? What we are trying to do? We are saying that I have a large triangle. I have drawn a perpendicular. I got two small triangles. I'm taking one small triangle and the large triangle. I'm saying both are similar, and that is what we are trying to prove. We are seeing one angle is 90 degree here. Larger triangle has 90 degree here. They have matched. One angle has matched. Second angle is anyways present in both the triangles. So be the large triangle, be the small triangle. This is present in both the places. It's the same. So two angles have matched. So third angle has to match. No doubt about it. Do you guys agree or you don't agree?
Yes.
Everybody? Everybody? Dixit? Yeah. Alright. So now, what happened because of this? Now we are saying that we did enough of circus and drama here. These two triangles are similar. Meaning, when I had a right angle triangle, from this corner I have drawn a perpendicular, then this small triangle is similar to the large triangle. Now, same way, if you look at this small triangle, I am saying this is also similar to the large triangle. Can you think about it? This side of the small triangle is also similar to the large triangle. Because this triangle also has a 90 degree, large triangle has a 90 degree. This angle is common in both the triangles, the small one or big one. So third angle has to match. Yandrud.
Wait, never mind, nothing.
No, but no, so it's okay. I'm just trying to confirm that I'm trying to derive a theory out of what we have discussed so far. Meaning, if I have a right angle triangle, from the vertex of the 90 degree, if I draw a perpendicular on the opposite side, this creates two child triangles, and both the triangles are similar to the parent triangle. Is that a fair statement? Yep, Anirudh.
Okay, so does that mean that all right triangles have like the same angle?
Not really. Not really. You can have a right angle triangle. This is 90 degree, this is 30 degree.